Hi everyone. So I wanted to make you a short video to give you more of a chance to look at and analyze the igneous rock specimens that we looked at in class. So let's start with intrusive igneous rocks. And I'm hoping that by now you can recognize a lot of these. This is I4. If you happen to have your igneous rocks lab, it might be good to pull it out so you can kind of follow along. Anyway, this is I4, and you can clearly see it's a pretty coarse-grained rock. There's a centimeter and millimeter scale down at the bottom of the video for you. So the typical crystals in this rock are several millimeters at least in size, and they include potassium feldspar, which is the pink stuff, a little bit of quartz. The quartz is a little bit hard to see, but there's a grain of quartz. Let me see if I can zoom in a little bit to see some of the quartz better. Kind of hard to see, but some of the sort of glassy grayish grains, like right here, that would be quartz. A little bit more quartz up here. A lot of K-spar in this rock, fair amount of quartz, a little bit of plagioclase feldspar, and then also a few dark-colored ferromagnesian silicates. In this case, most of the dark-colored minerals are biotite. So can you name this rock? It has a low color index. Remember that color index just refers to the percentage of dark-colored crystals in the rock. So this rock has a low color index. The texture of this rock would be phaneritic. And given the low color index, we can say that this rock is felsic in composition. Can you name this rock? I bet you can. This is granite. Here's another intrusive igneous rock of intermediate composition. This is I2. And it kind of has a salt and peppery look, doesn't it? So like the granite that we saw a minute ago, this rock has a phaneritic texture, meaning you can clearly see crystals that are visible to the naked eye. The white crystals, the white color splotches that we're seeing in this case, are plagioclase feldspar, and then the dark crystals represent pyroxene and amphibole minerals. What's the texture of this rock? Well, because it's coarse-grained, it would have a phaneritic texture, and this rock is intermediate in composition, meaning it has a medium color index and also a medium silica content. This rock is diorite. Here's yet another intrusive igneous rock. This is I1. And at first glance, this is a pretty dark-colored rock, although it doesn't contain only dark-colored minerals. You can see a fair percentage of light-colored minerals, in this case, plagioclase feldspar, and then the dark-colored minerals which dominate the rock, at least by eye, would include a mix of amphibole and pyroxene. This rock has a phaneritic texture and a low silica content, a relatively high color index. Can you name this rock? This is gabbro. Okay, on to extrusive igneous rocks. This is I8. It's clearly light colored. That tells you that the rock has a low color index, a low percentage of dark colored minerals. It's also pretty fine grained. Most of the minerals in this rock aren't visible to the naked eye, although some are. You can see little black splotches in the rock. Those are, for the most part, biotite crystals. There's a pretty good biotite crystal right there. And overall, though, it's the light-colored crystals that dominate the rock, even though you can't really see the light-colored crystals with the naked eye. This is a fine-grained rock with an aphanitic texture. Some of you pointed out in lab that some of these biotite crystals, are large enough to make this rock or to give this rock a porphyritic texture. So we could say this rock has both an aphanitic texture and also a porphyritic texture. But it really is the aphanitic texture that dominates the rock. It has a low color index, high silica content. Can you name this crystalline rock? I'll bet you can. It's rhyolite. What about this one? This is I7. And this rock actually has a medium color index. It's not super light, but it isn't super dark either. And for the most part, it's a pretty fine-grained rock. We would say the texture here is aphanitic. However, if you look at the other side of the rock, you can clearly see these hornblende crystals in this case that are more than several millimeters in length in some cases. So we would say this rock has both an aphanitic and a porphyritic texture. It's intermediate in composition, meaning it has a medium silica content. This is andesite, and the andesite in this case has both a porphyritic and an aphanitic texture. Well, this is also an extrusive igneous rock. It's crystalline with a porphyritic texture. In this case, the large crystals, the large white crystals, they look kind of blocky in some cases. Probably by now you can tell me what mineral that is in this specimen I6. The large crystals, that is the phenocrysts, are plagioclase feldspar. And then the sea of much smaller crystals that generally aren't visible to the naked eye that you can kind of see here. I'll zero in a little bit. These darker crystals would be a mix of mostly amphibole and perhaps some pyroxene, more ferromagnesian silicates. In any case, if you kind of average the light-colored phenocrysts and the dark-colored matrix together, you get a rock that's intermediate in composition. So this rock as well would also be andesite, except that in contrast to the last specimen of andesite, this specimen of andesite has plagioclase phenocrysts rather than hornblende phenocrysts. So the texture of this rock, like the other rock we just saw, would be both aphanitic and porphyritic. And I'll bet you can recognize this rock. This is I5. And right off the bat, you can probably recognize a couple of different textures in this rock. Let me zero in a little bit, kind of focus in there. We have all these holes. These are frozen gas escape bubbles, so we know at a glance that this rock has a vesicular texture. But it's also pretty fine-grained, as you can see. You can't really make out individual crystals with the naked eye, although the crystals are large enough that you can kind of get a sense of the graininess of this rock. But in any case, this rock is pretty fine-grained overall. It has an aphanitic texture along with a vesicular texture. Pretty dark-colored. So we would say this rock has a high color index, and that means that it has a low silica content. So this rock would be basalt. Okay, I'm going to move on to the glassy rocks. This is I11, and I'll kind of put it down there. Probably you know at a glance what this is. You can see the kind of shiny glassy texture here, and that kind of divot-shaped fracture is known as a conchoidal fracture. Let me see if I can focus in on that a little bit and even zero in. There we go. So this glassy rock clearly exhibits conchoidal fracture. It's shiny. It's clearly glass. For the most part, this rock lacks crystals, and this shiny black rock is obsidian, of course. Now remember that obsidian actually has a high silica content despite its dark color. Remember that we can only use the color index to help us understand the silica content of the rock if the rock is crystalline. This rock is not crystalline. It doesn't contain any crystals, really. So it just so happens that this rock is both dark-colored and enriched in silica. So this glassy rock, as you know, is obsidian. And obsidian is an extrusive igneous rock. This rock, I10, also has a glassy texture, although you can't really see the glassy texture very well. You can see it better under a hand lens. But you can see the vesicles in this rock. This rock has numerous small holes. If I do that, you can better see the vesicles, particularly if I focus there on the small vesicles. And so we would say that this rock, let me zoom out a little bit, has both a vesicular texture and also a glassy texture. The density of this rock is so low that it actually floats in water, and I'll bet you can tell me what this rock is by now. of course, it's pumice. I'm going to go back to intrusive rocks for a second. This is an interesting rock that you looked at in lab, I4A. And let me find a good place to kind of zero in here. If I do that, and then I really focus in. If you look at the size of the crystals in this rock, they're quite large. That's a single crystal of potassium feldspar. That's another large crystal of potassium feldspar, much larger than even a centimeter in this case. So what's the texture of this extremely coarse-grained rock? What's the textural term? It would be pegmatitic. So this rock has a pegmatitic texture. A lot of K-spar, a lot of potassium feldspar in the rock, and then the sort of dark gray or sort of medium gray glassy minerals. Let me find a good place where we can see those, like right here. Right here. Kind of zero in there. So these sort of grayish glassy minerals here and here and here, that's quartz. And there's even a little biotite in the rock. If I kind of focus right there, let me zoom out a little bit, get a better view there for you. There's a good example of some of the biotite in the rock, that ferromagnesian mica with kind of the flattish crystals. So this rock, and let me zoom back out, it obviously has a very low color index, a very low percentage of dark colored crystals in the rock. A lot of quartz, a lot of K-spar. This rock is granite, but it's pegmatitic granite. That is, it's granite with an extremely coarse-grained texture that we refer to as a pegmatitic texture. A couple more to show you. This is a specimen you haven't seen before, but since I'm at home, I have a better specimen than I showed you in lab. This is a pyroclastic rock, so it's extrusive in origin, and let me kind of zoom in a little bit. So you can see the fragments in this case tend to be pretty small. Some of them are about a millimeter or two in size, but most of them are so small you can't even really make them out with the naked eye. Overall, this rock kind of has a little bit of a chalky feel. See, when I kind of rub the rock, it's sort of kicking loose some of the small pyroclasts. This is essentially hardened volcanic ash. Particularly when I rub the rock with my thumb, you can kind of see that it has a sort of ashy nature to it when I break loose some of the tiny pyroclasts. So what's the rock that is essentially hardened volcanic ash? It's a pyroclastic rock. This would be tuff. This is maybe more typical of what you see in tuff than the example that we looked at in class. So I wanted to show you what tuff looked like. And then let's compare that to this specimen. You saw this one in class. Let me kind of zoom in here. So this is much coarser than that tuff that we just looked at. And in this case, each of those fragments that you can kind of see here and up here, each of those fragments is a rock in its own right. And these rocks are just sort of clumped together into a coarser grained pyroclastic rock called volcanic breccia. So again, this is what volcanic breccia looks like, very grainy, visibly coarse-grained, although the grains in this case aren't crystals, but they're rock fragments, generally larger than a millimeter or two in size. So again, volcanic breccia, I13, and for contrast, again, this is tuff. So tuff and volcanic breccia. Okay, one more I'm going to show you just because it's a pretty cool rock. See if I can get a good surface here. I might have to even zoom out to really take in the properties of this rock. Here we go. This isn't really a true granite. It doesn't have enough quartz in it, but what's amazing about this rock, look at the size of that potassium feldspar crystal. That's one single crystal of potassium feldspar. There's my thumb for scale. That's a really large crystal. It's also got some plagioclase in the rock, some plagioclase crystals, and then some ferromag silicates, hornblende, and pyroxene. So what texture would this rock have? Well, the incredibly large K-spar crystals embedded in the rock give this rock a porphyritic, phaneritic texture. So this part of the rock has a phaneritic texture, and then these much larger crystals here and here, these K-spar crystals, give the rock a porphyritic texture. So this intrusive igneous rock has both a porphyritic and a phaneritic texture.